Hello. Hi guys, welcome to another live session by Great Learning. So guys, in this live session, we will be covering DevOps interview questions. So before we start that guys, please give me a confirmation in the comments or the chat so that you can hear me and that you can see me so that I can, proceed. There's a little bit of lag, so, I'll have to wait a little more. Well, while you guys, giving the confirmation, I want to tell you guys about our Great Learnings initiative. So, guys, here at Great Learning, we started something called Academy, something called Great Learning Academy. So, if you're looking for a certification for completely free, we do provide this here. As you can see, we have a lot of different courses and free live sessions that you can go ahead and watch from using our website, and you can definitely start any course that you want that we provide you. We have a lot of different types of courses. We have data science courses, we have machine learning courses, artificial intelligence courses, and all of these are completely free, and you will get a certification once you complete them. So please make sure to check these out. Also guys, please subscribe to our channel and hit the bell icon so that you don't miss any of our future updates. All right, so let's start with DevOps interview questions. So what is DevOps and what are the interview questions? The one assumption I'm taking here is that you guys know what DevOps is, because if you're looking for DevOps interview questions, you should have some idea of what DevOps is. But if you don't, that's completely fine. If you just clicked on this to see what's happening, what's going on, let me tell you what DevOps is. So DevOps is something that we use in software development. Now, software development may look very easy, but it's a very long and arduous development process. You don't want to be stuck somewhere while you have to deliver at a particular deadline. So DevOps is something that helps us to greatly improve our efficiency in the software development process. There have been many different methodologies, and DevOps is one of the final incarnations. It's maybe not final incarnation, but as of now it's the most latest incarnation of a mindset slash culture slash methodology that we use to develop software. And right now we're going to be discussing all the different interview questions that you may be asked if you're going for a position that involves this role of being a DevOps. If you're going for this employment where they're asking you, or if they're going to be asking you for DevOps engineer or a related role like site reliability manager or infrastructure engineer, similarly you're going to have similar questions there. So don't worry, let's start off with all the different interview questions there are for DevOps. So the first question might be, can you explain to us what DevOps is? So the employer might want to test out whether you actually know what DevOps is. So this might be one of the first rounds itself. So when you want to answer for DevOps, right, it's not easy to give one definition for DevOps. But if you had to give, this is what you would start off with. DevOps is a set of practices that combines software development and IT operations. It aims to shorten the system development life cycle and provide continuous delivery with high software quality. DevOps is complementary with Agile software development. Several DevOps aspects come from Agile methodology. So what's being said over here is that DevOps is a mix of two things. It's a mix of software development and it's a mix of IT operations. So in operations, you want to make sure that you are deploying your software properly, and developer is basically you're developing the code. So it's a mix of both of these things. The name DevOps itself comes from that, developer and operations. So you have your developer, the dev comes from there, and operations, the op comes from there. So that's your DevOps. Now, DevOps bridges the gap communication between the software developers and the IT operation team. So if you're going to be going for a DevOps engineer role, you will have multiple tasks. One of your main tasks will be to make sure you have a very well performing software development pipeline that is situated on a established infrastructure. That is one of your jobs. You have to make sure that you involve automation in every part of the process, or in every part of the process where it's possible to introduce automation. That's your job. And once you've done that, you want to make sure that the communication between the different teams is handled properly. There are no miscommunications. The ideas are exchanged properly from the developers to the testers to the operations team. Everyone, is able to communicate, and all of them have that one mindset in mind, that they are working to deploy a software so that the customer gets the software, the product, the finest version of that product or service is given to the customers. So that's the main goal that every person working to develop this software should have in their mind. And as a DevOps person, you are responsible for putting that mindset. So DevOps is not just a methodology that you guys might think to compare with Agile or something. DevOps is like a lot of different things. You can say DevOps is a culture, the culture you have at working in a company where you're developing the software, or it's a mindset that these people have when they are making the software, or you can say it's a methodology. It's a mix of everything. You can even say that the tools that are being used in DevOps, they're also a part of DevOps, and you can say even automation is DevOps. So there are like a lot of different definitions, and mostly all of them combined from what DevOps is. So I hope you guys understood what DevOps is. Now let's see the next question. So the next question is, how do Agile and DevOps differ? So a lot of times people have this confusion between Agile and DevOps. So an employer might want to make sure that you know the differences, because Agile and DevOps aren't completely the same thing. So let's see what the differences are over here, or what are the similarities in Agile and DevOps. So we have Agile methodology. Now, the whole idea of Agile is to make sure that teams can work faster and more efficiently in regular sprints, and to keep on improving based on feedback given to them. Earlier, Agile was used only by developing teams. It hadn't trickled down to other parts of the whole software development process. So while successful at improving the development speed, testing and operations was still lacking, and that's where DevOps comes in. So the whole idea of Agile was originally implemented only with software developers. It wasn't really implemented with the testers and the operations team that was responsible for deploying the software. So with that, a need to improve testing and operation was realized by a lot of people. It was achieved with the help of automation, and that's where the concept of continuous integration emerged. So if you know what DevOps is, you will understand that continuous integration is a phase in DevOps where you integrate every other part of the software development process. You integrate the development part, you integrate the testing part, the deployment part, the continuous monitoring part. You integrate all of it together. Companies small and big quickly took up the initiative and improved the delivery parts as well, not just their development part, but also their delivery parts. Then onwards, Agile and DevOps were used in unison to develop and deliver software. So what's being said over here is that Agile is a great methodology, but it didn't really help us in the operations or the deployment part, where we want to make sure that the software is being deployed properly, the whole process of it being deployed. So we started to make use of DevOps. So generally when you talk about DevOps, it will not be implemented by itself. You will be making use of Agile in certain places. So in software development, when you want to develop a software, right, the team that develops the software will be using an Agile methodology where they will be working in sprints, small sprints of maybe 1 week or 2 week, depending on their requirements, and making software in that 1 week, 2 week, and then sending it ahead for deployment purposes. So there you're using Agile, and then DevOps you're using the rest of the part of the whole process. So Agile and DevOps generally are used in unison together when you are working in software development. Okay, then another question that you might be asked is, why DevOps in the first place? Why is DevOps such a big deal? Why is it so huge in these markets? So an answer you can give them is, you can go back to the original way of developing software. You can tell them that we used to have something called waterfall model. Now, waterfall model was something that came up in the infancy of software development. It was back in the 80s, was actually 60s to 70s to 80s. These 3 decades, that's when the whole software development actually started. But previously to that, it wasn't as prevalent. And even then it was just, in research labs or in government facilities, where they have the military doing it. So that's where software development was, originally implemented and used to make software that would help them, do their research or help them in some weapons development program. So at that time, they didn't have a need to develop software at the end of every 2 weeks or at the end of every month. So they took their, sweet time to develop the software. And they used to use a model called waterfall model. So let's look at what the waterfall model is. A lot of you already may know what it is. So if you have the waterfall model, you see the first phase is checking the requirements, where you check what are the requirements for your software to see what will it need and how will you be implementing it. Then you go to designing phase. So in this phase, you will design every part of the software, where you will design the architecture of it, where you will assign the task of implementing these to other teams. You will schedule these tasks, etc., etc. Then you have the implementation phase, where all the different teams implement the software. Then you have testing phase, where you test the implemented software. Like once the software has been created, that created software will go ahead for testing, where it will be tested for all the different requirements that had been set in the requirements phase. Then you will go ahead and deploy it. Once it's been deployed, you will go ahead and try to maintain it. So you can see it's a very big process, and it takes a long time in waterfall model. But that's fine, because you're going with the assumption that it will take us a lot of time, but we are going to deliver something really polished and really big. In early years of software development, when it was just coming up, waterfall model was used. Now, waterfall model is very standard model used in many different fields. So it's not a software thing. It's just, software appropriated it. It was very useful when requirements were concrete and the development life cycles were very long. So there it made sense. But the thing is, it didn't make sense in today's market, because we know that today's market is very hungry. It's very thirsty. It needs a product or a service every other day or every other month or every other week. So waterfall model could not catch up with that. And its drawbacks, they became really, really loud in this kind of environment. So if you look at the drawbacks, you can see that it's very long development life cycles. It takes a very long time to develop a waterfall model, and it is very difficult to backtrack in this whole process. Once you see in testing that there is some issue, or if you see a issue in deployment itself, you see that the application has crashed, you have to repeat the whole thing again, and that's again a long development life cycle. So it takes time. So it's very difficult to backtrack. You have to use more resources. The amount of budget you require will increase, and that will give us more problems. And no finished product till the end date. So in these days, you have to show that you have completed something. With waterfall model, you can't show that. You have to wait for the whole process to finish. Only then can you show a finished product. But these days, that's not the case. And it's tougher to plan for, because you're developing on such a long scale. You can't be aware of all the different variables there might be present, and you can't exactly plan for them. You can just approximately plan for them. In shorter life cycles, it's easier to do this. And it's higher risk. So it's like high risk, high reward. You don't know what you're getting at the end, right? So you don't know if it's going to be successful. So it's like high risk, because if you fail, you have to start all over again, or you're losing a lot of your money. So these drawbacks, they became even more louder when this kind of market came along, where the whole software development became commercialized instead of just being in research labs. So because of commercialization, we started to develop new methodologies, like your spiral methodology, extreme programming, agile methodology, lean, kanban, all those different frameworks of agile also. And DevOps was a part of it. DevOps came into the scene after those methodologies were implemented. DevOps is something that started like around like the name itself was started like some 10 years back or something. But the whole idea of it was there a little earlier, but it was started being implemented properly, I would say, from 2010 onwards. Like, a lot of companies are implementing it. So DevOps says that it doesn't need all of this. It automates everything. It automates the whole process of software development, every little part, and tries to reduce the amount of human intervention as much as possible. So that's what DevOps does, and that's why DevOps is so important, and that's why it helps us so much. It gives us a lot of different benefits for software development. What kind of advantages will you see on implementing DevOps in software development? Now, this is another question that they might want to check if you know, because knowing DevOps is a lot more important, because you need to know how it will affect everything. So this might be a question that they might ask. So you can answer with the benefits of DevOps. Like, these benefits are like productivity increase. You're definitely increasing the productivity you have for your software development. You are making sure that every process is as efficient as possible, and in making sure that you're increasing the productivity of it, you're reducing the amount of time taken to do something from 1 hour to maybe 10 seconds. So productivity definitely increases over here. Then excellence. When I talk about excellence over here, what I mean is that the product, the whole value of the product will be like a ruby or a diamond. It will be the best product that you have delivered. It should be the best product you delivered. And with DevOps, that is possible. And that will definitely make the customers happy, as well as the stakeholders or the people who are running the organization who are making the product slash service. Because you're giving an excellent product and you are receiving the same amount of profit or revenue that you generate. Returns. Again, I was talking about profits here. So the amount of returns you will see, the revenue that you generate as an organization on implementation of DevOps is greatly increased because you are very efficient, because you're delivering an excellent product. Now, a lot of other benefits also include like, speed and rapid delivery. You have amazing speed of developing the software. Again, it relates back to efficiency slash productivity, and you're delivering the product rapidly. So since you're delivering the product rapidly, you are making sure that the downtime for your service slash product is very less, because you're able to give a quick fix or a hot fix very fast, and that again makes the customers happy. Robust security. So when you're implementing DevOps, there is a whole section of DevOps called Sec DevOps, where it's it concentrates on making sure the whole pipeline is very secure. It makes sure that the whole software development process is secure. There are no vulnerabilities in your code. So that's where you also make use of static testing to make sure that your code is secure. Then it again gives you the option of scaling. Now, scaling is very important when you're looking at a startup or a business that thinks that it's going to be growing very fast. If you're going to be growing at a very rapid rate, it would be very hard for the software development team to catch up if they have not written the code for scaling. If you've written a code in some legacy software which is not supported anymore, then that will represent as a problem in later stages of your company's growth. So you need to scale properly. So you need to plan for future, and DevOps helps you with that. DevOps helps with better scaling options. Okay, another question might be that how to implement DevOps within a project. So this is a question that they might definitely ask you, like where they will ask you, how would you implement DevOps for a existing project? So there are a few steps over here. Now these steps aren't concrete steps that you have to follow, but these are the generic standard steps that you might have to follow when you are explaining how DevOps will help you with with improving a existing project. So let's start. So step one, understand the currently existing software development process. There might be an already existing software development pipeline, and you need to understand it. You need to understand every aspect of it, because then you will understand all the requirements of it. Understand what kind of software is being developed. You definitely need to know the business in and out. You need to know what kind of product is being delivered and how can you improve on that product being delivered. And you need to know what kind of resources your company has at hand, because this is again like kind of planning. So you need to understand everything in the starting. Your job will be to just observe. Once you observe everything, once you gather all the insights and the details, then you can move on to other steps. Then you need to identify the places where improvement can help improve efficiency. So in the currently existing software development process or the pipeline, you will look at every small thing. You will try to find out where an improvement can be made. So you will note that down, that I can make an improvement over here, and I will implement that improvement later. Then we come to the second step. So once you have understood all of the requirements and you've understood the whole software development process in and out, and all the resources being used and what kind of product is being delivered, then you can go ahead and create a plan and prepare an environment for that plan to be executed. So you are going to be writing down a plan. In this plan, you will write down all the things you will need, all the ways you will improve the already existing software pipeline. You will create a plan first. That is very, very important. And a good pipeline must be established on strong infrastructure. So you need to not only plan the whole software development process, but you will also have to plan out what kind of infrastructure will it stand on. When I talk about infrastructure, you have to understand that when you're deploying a software or when you're creating a software, in that whole pipeline itself, you have to make sure that each part is supported by some kind of infrastructure. When you are deploying a particular software in testing environment, where is that testing environment? Where is that staging environment? So all of those things have to be supported by some kind of servers where you will launch these things. What kind of tools will you be using to launch these things? So all of those things have to be kept in mind. What kind of cloud service are you using? And if you're using a specific cloud service, are you making sure that the cloud service you're using is the most efficient one? Because have to maintain cost effectivity also. You have to make sure that the cloud service you're using and the services you're using are the most effective one as well as the most cost effective ones. You can't be spending a lot of money. Your job is to make everything as efficient as possible. So you have to take cost effectiveness in mind when you're doing this in the whole planning process. And you use your services, you establish a pipeline, you draw it out, and that's your plan has been created. Then starts the step 3. Start with baby steps. You know some of the glaring problems with the already existing pipeline because you've done the first step, that is observing. But try not to disturb the entire environment. That you have to make sure in the start, because you are going into this new thing and you need to make sure that you don't disturb an already established pipeline. If you do disturb it, you're still learning about it, so you need to slowly start implementing your changes in. So you should instead try to implement small scale changes to test the waters. Like, don't like overhaul the whole pipeline in the first go. Make sure that, look at one specific part of it. Let's talk about, for example, testing. Now, the testing before you came in used to happen manually, where, the whole code came in. So the tester had to manually run his test scripts on the whole code, and he had to check for, load balancing, and he had to make sure that every part had been integrated with each other, acceptance testing, all those kind of things. But you start to implement this new feature that all of this gets tested automatically. There is no human involvement, there is no human involvement in this, other than the fact that somebody has written those test scripts. So that's the first change that you can make. That's just an example. Maybe first implement changes to one part of the development. If successful, move on to the rest of the pipeline. This is how you would do it, step by step, and you will start with your baby steps. And you won't do it completely once. You will do it, step by step. All right, so then it comes step 4. Completely establish the new infrastructure and test the new pipeline in place. Once that is completed, start developing and deploying the software using the new pipeline. So this will happen actually over a set period of time where you've established a new infrastructure, or it can happen on a overhaul thing where in the start you won't do an overhaul, but maybe based on new requirements, you might be working on this pipeline in the back while the existing pipeline is still working. And once you've tested the new pipeline out, you've made sure that this pipeline works as well or much better than the existing one. That's when you're going to replace it. That's when you're going to replace it. That's the step 4. And then step 5. Start implementing an agile/lean culture within the different teams. So this is again important. As a DevOps engineer, you're not only an engineer who's solving problems. You are in the tech department, but you're also solving problems on an interpersonal level. You will be in a higher position, so you need to make sure that the boundaries that are set between the different teams don't cause any miscommunications, but rather allow for insightful analysis. The teams should be talking to each other very well. There shouldn't be any passive aggressiveness. There shouldn't be any company politics being involved, because our end goal is to give the customer the best software there is. So that is our main goal. And to make sure that happens, a DevOps engineer is responsible for maintaining these amazing interpersonal relationships. Because as a DevOps engineer, you will be talking to all the different teams, not just one. Because a DevOps engineer is kind of like jack of all trades job, where you are, talking about databases, you're talking about the software development, you're talking about the operations, you're talking about the testing. So you need to know all of those different concepts. So you will also need to talk to all these different teams. You will have to talk to the database administration team, you'll have to talk to the development team, you'll have to talk to the testing team, etc. And you have to maintain amazing communications between them. So make sure that there are no miscommunications, because that again is a big wall. It's a hurdle in our becoming a better organization and delivering better product. All teams should be looking at development, deployment as a part of their final goal. And then comes step 6. Okay, so in step 6, you have to understand the feedback from the team as well as the customers. So once you receive a feedback from the team, because again, you are developing a pipeline. So here the feedback of the teams also matters, because they're the ones that are working on the team, on the pipeline. You're not working with the pipeline, but they are working with the pipeline. So you need to make sure that they are comfortable. If the development team is not comfortable with the infrastructure that you've given them, it does not fulfill their requirements, then what's the point? They will definitely give a feedback to you, the team as well as customers. They will give a feedback to you, and you will improve upon the whatever you have planned and whatever you have established accordingly, and implement those changes based on those feedback that you have. You have to start a positive feedback loop. So this is how you guys would implement DevOps in a project. So let me just reiterate this. In step 1, you will understand and observe whatever already exists. In step 2, once you've understood everything, you will start the whole planning phase, where you plan the pipeline out, where you plan the establish, where you plan the infrastructure out. And then third step, you will slowly start getting and start making the changes. In step 4, you will do the complete overhaul after a period of time. And in fifth, you will start implementing a culture around the whole development process, where all the different teams are able to talk to each other. And finally, in the sixth, you will improve upon whatever you've done by taking in feedback from the teams as well as the customers. So this is how you would implement DevOps within a project. All right. So another question might be, what are the main phases implemented in DevOps? Now, we know that DevOps has multiple phases, so you can go ahead and tell them what are the different phases are. So in DevOps phases, you have your first phase, that is continuous development phase, where you're continuously developing the software. Then you have continuous testing phase, where you're continuously testing that software that is being created. There is no stoppage. And then you have continuous integration. This I've talked about already. It's about connecting every other part of software development process. Then you have continuous deployment, where you're deploying the software continuously. You're not waiting for someone's input to deploy this software. You are doing this continuously. And finally, you have continuous monitoring. Now, continuous monitoring is also very important, because once you've deployed your software, you need that feedback from the customers, or you need that feedback of how your new software is doing. Maybe it's a new version of the software. So you want to continuously monitor how well it is performing. The application performance metrics should be monitored. The logging should be monitored. All those different things should be monitored. And those those visualizations and that insight that you get from monitoring these should be utilized in the next cycle of development, or in the next cycle of improving the whole pipeline. So these are the different DevOps phases. Keep them in mind, they're very important. Another question will be, what are the different tools that are implemented within DevOps? So DevOps has many different fields, and these many different fields have many different many different tools that are being used. So let's look at those tools. We will understand a little bit more about DevOps when we see all the different tools being used. So we have continuous development. In this, you use version control systems. Version control systems can be your Git, Mercurial, Azure repository, or AWS code commit. Whichever version control system you're using, they are part of the continuous development. And also you will have integrated development environments, but that's a local thing. That's not the part of the complete software development process. Then you have building tools. So in the whole development process, you have to build the tool also. Like, you have to build the software also. To build the software, you use tools like Ant, Maven, Gradle, MS Build. Now Maven, Ant and Maven are very similar, but Ant is an older version, like it's an older software, and Maven is the one that is used for Java. It's used to use build Java code. Gradle is for Android code, and MS Build is for your Microsoft code like .NET and C#. Then you have database management tools like MySQL, MariaDB, and LiquidBase. And you will also have MongoDB and all the other any cloud services that might be there that provide database, any RDBMS. So you need to know these also. With continuous testing, you have tools like SonarQube, Selenium, PyTest, Catalan. They have their own unique testing things, where Selenium is for dynamic testing, SonarQube is for static testing. Then you have continuous integration, in which you have tools like Jenkins, CircleCI, GitLab, Bamboo, TeamCity. Git has its own thing. GitLab. So all these different tools, right? They are basically connecting tools. They are the main root things. This is where you make the jobs. These jobs will be executed, and within these jobs you will list down whatever you want to happen in your software development process. Then you have continuous deployment tools like Excel deploy, Juju, Octopus deploy. So these basically help in more efficient deployment of a particular software. So you will be using them in conjunction with continuous integration. But sometimes if you're using Jenkins, you don't need to use a deployment tool. That actually depends on your requirements. Maybe if you want to have more in-depth knowledge on the deployment, then you go ahead for the continuous deployment tools. Then you have more tools like continuous management, configuration management tools. Now, configuration management, it's basically where you're configuring different. You have a lot of systems at hand, and you want to configure them together. So you make use of these tools because you can't go one by one and make those changes. You need a Puppet, Ansible, Chef, or SaltStack. They help you make these configuration scripts that you can run on these different systems. Just have to push them once, and all the updates will happen by themselves. Then you have orchestration tools. Now, I can't go into detail for what orchestration tools are, and I hope you know what these already are. So you have Docker, Kubernetes, Nomad, Apache Miso, EKS, ECS, and if Google has its own, and Azure has its own orchestration tools. So these are the different orchestration tools that you can make use of. Then you have artifact repositories, JFrog Artifactory, NPM, that is Node Package Manager, and then you have Sonatype Nexus. Then you have cloud services. Now, cloud services also play an important role in DevOps because you're creating your infrastructure and your services. You might need different services. So you have AWS, Azure, GCP, OpenShift, Cloud Foundry, DigitalOcean. All these different cloud services provide you the tools you might need. And you have continuous monitoring, which is again important. So you have tools like ELK Stack, Prometheus, Grafana, Splunk, Nagios, Google Analytics, whatever you guys use. And then finally has scripting. So scripting is basically a technology where you need to write automation scripts. So to write those automation scripts, you can use either any of these tools. You can use Python to write your automation scripts. You can use PowerShell, Perl, Java, or .NET. All right, so these are the different DevOps tools. Now let's move on to the next question. So another question might be, is continuous delivery the same as continuous deployment? Now they look very similar at hindsight, in just looking at it, but they're kind of different. So let's see the difference. So there is a very simple difference between these two. In continuous delivery, the software is not automatically sent to the production server. Beyond that, it actually requires human involvement for the final deployment to the client customer in production server. That is your continuous delivery. But with continuous deployment, the software is automatically sent to the production server and requires no involvement from humans. Only thing that can stop this process if a specific test case fails. So, the difference here is that in delivery, you still have some human involvement, but with deployment, you don't have any human involvement other than, creating it in the first place. So these are the differences. Okay, what is containerization in DevOps? So this might be an important question because containerization plays a very major part in DevOps. So let me explain this. So let's look at this standard delivery pipeline. This is without DevOps. This is before DevOps or any Agile or anything. This is just deploying the software. So what happens here? We see that the developer writes the code. This code can be for anything. It can be for a website. And this code needs certain dependencies. These dependencies can be libraries or functions that are required for this code to run. Then this code is built. That means it's converted into an executable. And once this executable is created, the tester tests it out for all the different testings, unit testing, integration testing, and acceptance testing. All these different kinds of testings happen. Once the tester is satisfied with it, he will say that it's good to go ahead for deployment, and it will go ahead and get deployed. But if there are some issues, and if it doesn't get deployed, the whole process starts again. The tester tells the developer that this is the issue. The developer will rectify these issues, and then he will go ahead and do the whole process again. So this is a standard delivery pipeline. How can this be improved? But the thing, what we didn't talk about is the issues we faced here. So guys, you can go ahead and check out my Docker video where I talk about this in even more detail. Go ahead and check it out. It's Introduction to Docker on Great Learning itself, where I go into a little bit more details for you guys to understand. But in short, what I'm trying to say here is that developer and tester, right? They are people with their own environments. They have their own laptops. Maybe the developer is using some other laptop and tester using some other laptop. They're using different operating systems, or maybe they're using different versions of specific software. If the developer is using PHP, PHP 7 or some particular version, and the tester is using an older version, so that the code that the developer writes will run on his computer. That will work totally fine because He's the one making sure it runs. But when it goes to the tester, the developer doesn't know about the tester's environment. So he just sends it thinking that it's all fine. And the tester takes it and tester tries to implement it himself. But the thing is, tester can't do it because it's not running on his system. So there is that consistency that is missing over here. There is no consistency in the environments that the developer and the tester are using. So to mitigate this or to improve upon this, to make sure that the code is compatible with all of these processes, what we do is we introduce containerization. It is basically trying to contain the code. So instead of having them, send the code physically, what we do is we take the code, we take all the dependencies, we take all the environment that is required to execute the code. So let's say if this is a Python, it's a Django code for writing backend. You take the Django code, you take all these dependencies, and you take PyTest that might be required to test it, and you take the operating system that is Ubuntu, and you put it all together in one box. Like this box is called a container, and as you can see over here under the developer, this is the container I've put over here. So all of these four things will be inside of this container, and since the operating system is also here, you can execute everything inside of this. Once you've executed everything inside of this on a developer system, you see that it's good to go, and it doesn't matter which operating system you are on, this container will work because it has its own operating system. It's like a VM, but it's like a small box. It's not exactly a VM. So you just send this to the tester instead of sending your code and this thing. You send the whole environment itself to the tester. So now the tester says that, okay, yeah, it runs fine on my computer because there is no dependency of the container on the system. It runs anywhere. And this way we keep the consistency. Even in production environment, we keep the same container. We deploy the similar container because these are the requirements, and based on that the container is created, and that's how you deploy it. So this is what containerization is inside of DevOps. Okay, how is cloud integrated in software development? So let's talk about that. So we already talked about it a little bit when we were talking about it earlier, where we said that cloud is basically used to give all the different services that are required for software development. So in cloud services like AWS, Azure, and GCP provide many different services that are useful for maintaining an infrastructure. When you are making a software development pipeline, you need an infrastructure to support it in every part of the way. You need to know where your images, Docker images, are going to be stored. You need a place where you're going to have your database. You need to know where your testing environment is going to be opened up, where your load balancing environment is going to be open, where your staging environment is going to be, and where your production environment is going to be. Where are you going to test everything, and where are you going to deploy all of these things? So you need to have a infrastructure that supports it. This infrastructure can be your EC2 instances in AWS that you launch. Now these EC2 instances individually are basically like small servers that you can generate just by a small click on AWS. You don't have to create any physical hardware for this. You don't have to use any physical hardware for this. Or you will just explain your requirements to AWS. AWS will look at that you need 5 servers because you need 5 different applications to be deployed. So AWS will be like, okay, fine, yeah, I'll give you 5 servers. You just pay me this amount. So AWS will provide you these 5 servers and it will help you manage these servers. So you don't have to worry about managing these servers also. All you have to worry about is your code. That's all you have to worry about. You don't have to worry about if the server is going to go down or whatever. So that is the job of AWS because you're paying them also. Similarly, Azure and GCP also provide you these services. They can provide you like databases, storages, source code repositories, servers, and a heightened security. And you don't have to manage any of these things because AWS is providing you a service, so they manage it on their end. Now the amount of manageability that if you want to increase it, then definitely you can do that. There are many different services on these clouds providers. So it all depends on your requirements. So this is how cloud is in very simple terms integrated with software development. Why do we need to continuously test? It's another question that you will need to know. Like, why do we test? When we are implementing a whole system that will be able to run without any human intervention, it is obviously important to make sure that test scripts that run on the software to make sure of its acceptability are also automated. So you need to make sure that test scripts or whatever tests you're running on your system are automated. Why do we make sure of it? We have testers for it, right? So we make sure that it is automated because our end goal is to make everything efficient. Let me guys give you an example. Like if you talk about car manufacturing, in car manufacturing we have cars that are being manufactured. In the early days when Ford started the whole production pipeline, right? He had people assembling small parts. But as you see these days, the amount of jobs, the menial jobs that are being done by humans is very less. It's now done by machines. There are small machines that have small automations already programmed in them. So this increases the efficiency at which you're producing a particular product, as well as reducing the cost, because the cost of a human worker, over the years it increases, because you have to promote them, or you have to keep on paying them a monthly salary. But if you use that automation machine, you're reducing the amount, because maybe the automation machine costs a lot, but in a longer term it costs less. So if it costs like $1,000 to get that automation machine, the worker you still have to keep on paying over the years, so it will be like 4,000 over 4 years. But for the automation machine, you're still using $1,000 for that 4 years. So this is how automation helps. It reduces the costs involved. And this is not exactly what happens in software development. That's just an example. What I'm trying to say, why automation is important. So you're reducing the costs and you're increasing the efficiency. That's why you need to continuously test. Now, why test? Now, the software should be tested continuously, because with DevOps in mind, we try to make sure that software we are developing is of the highest quality. It should have no bugs. It should have no glitches or crashes in future. No code smells, no security vulnerabilities. You need to make sure of all of these things, because it's very important that the software we develop is highly polished. Everything should be tested for. It should be tested for all of its requirements that we had set in the requirements phase, and it should also be made sure that the crashes it has in future are also reduced. No technical depth should be acquired. So these things are important. That's why we continuously test. Can you tell us the various components used in Selenium? So if they ask you what are the various components used in Selenium, you can just tell them Selenium IDE, Selenium RC, Selenium WebDriver, and Git. And you can obviously go into detail talking about these different components of Selenium being used. Again, Selenium is a testing software that is used. All right. So what role does a VCS play in software development? Okay, what is a VCS here? I'm pretty sure a lot of you guys already know. VCS is a version control system. It versions your software, and it makes sure that it's stored in a very dedicated location, so you can share it or collaborate with anyone. So why do we need a VCS? What is the role of a VCS in software development? So a VCS, right? The purpose of a version control system is, as the name suggests, it controls the different versions of the code. The idea of a VCS meshes very well with the DevOps ideology. It allows for quick delivery of code and automatic job triggering. This allows for easy automation of the whole software development pipeline. So basically, when we talk about VCS, we are trying to say that it's a place where we're going to be storing our code, the source code. Whatever code you write, whatever script you write, it will be stored in GitHub or Mercurial, whatever you're using, Bitbucket or GitHub. It will be stored over there and it will be versioned. Now, versioning helps a lot, because when you want to go back to a previously working or stable version, it's easy to just click and go back. If you didn't have this versioning or this tracking, then what happens when you write a new software code and it doesn't run? You overwritten your previous code, right? So and now you can't go back. Like, it will take some time to go back. It will be a lot of effort and time again consumed to go back to the older version, because the older version was working and you want to go back, because you want the downtime for your application to be as less as possible. So if you go back and write it again, right, it will take a lot of time, and your application will be down for all that time. So instead of just writing again, if you had it version, you can just go back and deploy the previous version, and application will be up while you work on the new version. You see what are the issues. In version 1 was working fine, version 2 is not working fine. In version 2, so let's just deploy version 1 and let's check out what are the mistakes in version 2. So you check out all the mistakes in version 2, then you test it again, and once you see that okay, now it should work fine, you will deploy it. And similarly, you do with a version 3, version 4, version 6. So that's why it meshes very well with the whole DevOps ideology. It's for automation purposes, and it deploys very quickly and rapidly. Explain Git Rebase. So they might ask you like advanced concepts in Git also. All right, so Git Rebase. So let's talk about Git Rebase. So the Git Rebase command allows a user to shift a set of commits and give them a new base. It is similar to Git merge, but the difference here is that the history of commits of a branch is also carried over when it is joined with the current branch. So it might be a little confusing. Let me show you a diagram over here. So we have the master branch, and in this master branch, you have a feature branch where a particular developers, pulled the cloned the master onto his system, and he's created a new branch where he's writing a new feature for that software. He writes this feature, and he wants to merge it back to master branch. So he can use two methods. He can use git merge, but he can also make use of git rebase. So what git rebase will do is it will take all the commits that happened on the feature branch, it will copy them and will recreate them on the master branch. So it doesn't like transfer them, it just copies them and recreates them. These will be entirely new commits that are made based on the feature commits. Now why do people want to carry over these commits? So because you have a lot of commits here. The thing with git rebase is that it's very clean. What happens in merging is that every time you merge, a merge commit is created. So if you are working in a very busy software where there are like hundreds of developers working on it, and they're working the hundreds of developers working on it, and they're have hundreds of feature branches, every time they merge, a new merge commit will be created. Now this is not very efficient because you have a lot of merge commits and they clog up the commits. When you want to go back and check if there's any errors, you'll have to go through all these merge commits, and they aren't very useful over there because you have so many merge commits. So in that case, you will go ahead and use rebase because it copies the whole history of commits from the feature branch itself. So you know exactly what went wrong in this feature. If this feature was wrong, you will know exactly what went wrong because you have the entire commit history. So this is Git Rebase. Explains Jenkins architecture. So Jenkins has his own architecture, and let's talk about it. So this is how the architecture is. Like you have a Jenkins master node and Jenkins slave node and another Jenkins slave node. So why does it have these slave nodes? So Jenkins is a software that is used for integrating everything, right? And it runs build jobs on its server. So what happens is when you have a big company, when you have many different developing teams, right? And they all want to push their software code for deployment, they create their own build jobs. The problem here is that you can't have so many build jobs on one server because a server has limited resources. So that's why we have slave nodes, so that this job can be distributed. If you have 10 jobs, master will do 1 and slave will do 4, and other slave node will be doing 4. So master will have 2 and the other slave nodes will have 4. So this way the resources consumed are not way too much, and you're still doing the job. And whenever there is a change in the code, a pull will happen, and if from the Jenkins master, and Jenkins master will decide how to divide the jobs. It will see if it will check if the slave node 1 is idle. If it's idle, it will send the job to there. Now you can configure it any way you want. Maybe you want it idle, or you want to send the jobs to this particular slave only. Those are all the details you can configure within Jenkins itself. So this is the Jenkins architecture. All right, so list the DevOps KPI. They might ask you what are the key performance indicators of DevOps in software development. So there are a few key points of indicators here. There are a lot more. I've just included 3 over here. Like you have recovery rate, which tells you how fast can you recover from a crash state. If you've deployed a particular software, how fast or how long will it take you? What are the average time it will take you to come back to the previous state? To make sure that to recover the whole process. Then the second key point of indicator is speed of deployment. Now speed of deployment is again important because how fast are you deploying your software, like how long are you going to be taking to deploy it. That is again a key performance indicator. If you have made the software pipeline so that it takes only 10 seconds to deploy a software, then people will give you like a gold star on your chest. They'll be like, oh, good job. Then you have failed deployments. So you need to make sure you know how many failed deployments there were in a particular sprint or in a particular time period. So that is again a key performance indicator. All right, so they might ask you, how do you remove a Git commit? So, or go back to a previous Git commit. So you use okay, it's not here. So basically you make use of git revert. there's a git revert command that you can use to remove, go back to your previous git commit. All right, so explain the Docker ecosystem might be another question that you might be asked, because Docker ecosystem, to understand that, it's very important because you'll be working with Docker a lot. So let's look at the Docker ecosystem or the Docker environment. So Docker environment has many different things. You have Docker engine, Docker objects, Docker registry, Docker compose, Docker swarm. Docker engine is the one that is responsible for running Docker. All the different components in Docker will be run because of the engine. The engine consists of three parts: the CLI, the API, and the Docker daemon. All of these three things together allow you to create and manage all the processes that Docker produces. Then you have Docker objects. These Docker objects can be your Docker volumes, your Docker containers, or your Docker networks. So these are the different Docker objects. Now you have containers for containerization. You have volumes for persistent storage. Like containers themselves can't store everything permanently, so you need volumes that permanently store data. Then you have networks. Now Docker networks are used to connect all the different containers in Docker. Then you have Docker registry. Now registry is basically like a storage place where you store all the different images. So if you've created your own customized image where you have Ubuntu running as the operating system and you have Apache 2 as a server platform, and you have copied your code into it, so that is a specific customized image, and you will store it on Docker registry. Then you have Docker Compose. Now Docker Compose is a service within Docker that helps you create multiple containers at one time. So if you use Docker, you know that when you have to create a container, you use one command to run one container. So what happens when you want to run 5 containers at the same time? To do that, you write a script in Docker compose.yaml file. And once you write that script, you can go ahead, and execute a Docker build command that will build all these different services or containers. And when you create all these different containers, right, you might want to manage them using Docker Swarm. So Docker Swarm is basically an orchestration tool that helps you manage all the different containers in one cluster. You'll have one manager node and other worker nodes. So if you want to push any updates, you can do that. If you want to remove, scale your number of services you have, you can do that also. So this is the Docker environment. Okay, can you draw a basic CI/CD pipeline? This is again important because it's continuous integration, continuous development, right? Deployment. So how do you create a CI/CD pipeline? Well, I've already given you guys the basics when I talked about how do you implement DevOps within a project. Now, CI/CD pipeline, let's give you guys an example. I have a pipeline already over here. So you can see this is a very basic pipeline. Obviously, based on requirements, your pipelines will change. But I've given you guys a very basic pipeline to give you an understanding. You can also draw a basic pipeline. So what will happen actually is that they might ask you to draw a CI/CD pipeline and they'll give you some requirements. And based on those requirements, you can go ahead and create that pipeline. So here you can see there's a developer. The developer writes this code, and once he writes that code, he sends it ahead for to be stored in the source code manager. This is basically your VCS, version control system. So once that code is being stored, a CI/CD tool will automatically detect if there is a new change or if there's a new code being pushed. And if he sees that there is a new code being pushed, it will automatically trigger a build job that is you've already written over here. That build job will start executing. So in that, what will happen is it will start building that code. It will take the software code, it will take all the dependencies of it, it will make it into one single executable file. That executable file will then go ahead for testing. It will be opened up in a testing server where you will test out every possibility. You'll run all the basic test scripts and etc. If you see that there is an issue, you will send that feedback will be automatically sent to the developer, and the developer will know about the issue, and he will repeat the cycle again until the code passes all the tests. Once it passes all the tests, it will go ahead to the staging environment. So the staging environment is basically like waiting, like you put all the production candidates. Now whatever code he sent will be stored in the staging environment as a production candidate, and now it will be wait for approving, and once it's approved, it will go ahead to production. If one of the candidates for some reason wasn't approved, it will the whole process will repeat. So this is a very basic CI/CD pipeline. All right, what is the role of configuration management in DevOps? So we have come to our final questions. So what is the role of configuration management? So configuration management, look at this definition that I picked up from one of the websites. Configuration management is a process for maintaining computer systems, servers, and software in a desired consistent state. It is a way to make sure that a system performs as it's expected to, as changes are made over time. So in basic, what we use configuration management for in DevOps is basically making sure that host environments on everyone's laptop server or laptop system remains the same. Like if you have hundreds of servers, or if you have hundreds if you have hundreds of servers and you want to make sure that these hundreds of servers have a specific environment, like if you want to install Apache server on all these hundreds of servers, then you can use configuration management tools to do so. You will write a specific script and you will execute that specific script on these hundreds of servers. So this is your what configuration management tools are used for. And this is what configuration management is used for DevOps. It's used to maintain, again, consistency in those servers. Okay. And if you want to push any updates or anything, you can do that also. So it has a lot of uses. A lot of people make use of configuration scripts to do specific tasks. So what are some configuration management tools? So you have tools like, you can tell them you have Puppet, you have Ansible, Chef, SaltStack. Most people use Puppet, Ansible, and some people do use Chef and SaltStack also. So guys, these were the different interview questions that you might be asked when you're going interviewing for a DevOps engineer role. Now remember that these aren't like the exact questions people will ask you. They will ask you different questions based on their own requirements. So if a person wants to know if you know Ansible properly, they will ask you all the questions on Ansible because they expect you to know about it. So this is how it works in companies, right? Based on their requirements, they will ask you questions. But this gives you a good base to understand how these questions are going to be, right? All right, guys. So that was it for this live session. I hope you guys, got something out of it. I'll give like 3 minutes for taking questions from you guys. So go ahead and type in questions in the chat. So I'll try to answer them. So there's a lag. So if you ask a question, it will take some time for me to answer, like 1-2 minutes. Okay, so I already see a question over here. Only Selenium can be used, or any other tools used for automation? Yeah, I mean, it really depends on what you're comfortable with. Like Selenium can be used if you're very comfortable with Selenium. Yeah, have you worked on Selenium before? If you have, then you can go ahead and use Selenium. But there are other automation tools also. If you just want to write some specific scripts, then you can use the specific scripts also. Now, if you have some specific test cases and you want to use a specific software, you can use it. It's always based on requirements. And it's always based on requirements that help you effectively, cost effectiveness, and efficiency of the whole pipeline. So do you guys have any more questions? All right, then I don't see any questions, so I'll assume that you guys really like my session. Okay, I'll see you guys in the next session. Thank you so much for watching. Also, guys, don't forget to subscribe and hit the bell icon so that you don't miss out any of our sessions, live sessions.